You've had a little chance to explore how scale factor impacts shapes, and today we're going to kind of formalize that with an example and then some facts. So we're going to look at these two rectangles, and I want you to think about the impact of scale factor. So these are similar figures, and I want to know what is the scale factor from rectangle A to rectangle B. So I'm trying to think about, for this small shape, what do I have to multiply the side lengths in A to get to the side lengths in B? So you're going to notice 2 times 3 is 6. 4 times 3 is also 12. Our scale factor from A to B is 3. Second question is, how do the angles of shape A and shape B compare? So you're going to notice these are rectangles, every single one. They are the same. In similar figures, this will always happen. So they are equal. The third question says, how many times larger are the side lengths of B than A? You probably noticed you already really figured this out when you figured out scale factor. So B, its side lengths are 3 times as large. 3 times larger. 12 is 3 times as big as 4 is. 6 is 3 times as big as 2 is. The last two questions might involve a little bit more work. So the first one asks us, how many times larger is the perimeter of B than A? So for now, I would like you to actually figure out the perimeter of B and the perimeter of A so that we can compare them. So we're just going to add up all the side lengths. So for B, we're going to add 6 plus 12 plus 6 plus 12, because don't forget about these extra sides. And so when you add, oops, I put an equals instead of a plus. When you add these, you're going to get that the perimeter is 36 units. And for A, I'm going to add 2 plus 4 plus 2 plus 4, and I'm going to get a perimeter of 12 units. And notice if I do 36 divided by 12, I get an answer of 3. So the perimeter of B is 3 times as large as the perimeter of A, which probably doesn't surprise you. Okay, the last one's where it gets a little tricky. How many times larger is the area of B than the area of A? Well, let's find the area of each shape in this case. So the area of B we're going to do is a rectangle, so 12 times 6. That's an area of 72 square units. For A, I'm going to use 2 by 4, 2 times 4. That's an area of 8 square units. So how many times bigger is the area of B than A? I'll do 72 divided by 8, and I get 9. So it's not 3 times bigger. It's actually 9 times bigger. It would be very convenient if you notice that 9 is equal to 3 times 3, or 3 squared. So it's actually 3 squared, or 3 times 3 bigger. Notice because we had to multiply both the length and the width, so we really multiplied by 3 2 times. So 3 times 3, getting to 9 times larger. Okay, let's summarize, because these impacts of scale factor are actually always going to be true. So no matter if it's these shapes or even if it's even a rectangle, certain characteristics are always true. The first one being, if the scale factor from A to B is x, the side lengths of B will always be x times larger than A. So if it was a 5 scale factor, they would be 5 times larger. The perimeter will always be x times larger than A. So the perimeter grows in the same way. It would also be, in that case, 5 times larger, or whatever x is. The area of B will be x squared times larger than the area of A. So in that example, it would be 5 squared, or 25 times larger. And lastly, A and B, if they're similar shapes, they're always going to have the same shape and the same angles. So this summarizes, and these are kind of cool facts that might have surprised you, and they are always going to be true.